Hello dear students. So in this session we are going to see that how to solve differential equation of the first order and first degree. Okay. So in some of our next sessions we will discuss these methods in details, but in today's session we are going to see that okay, for what type of case and what method we should apply. Okay. First and foremost, if you see the methods of solving first order and first degree differential equations, that means what? The differential equation will have something like this: dy dx, then x, y, it will be a function of this. Okay. For example, if we have an equation something like this, that dy dx is equal to e power x plus y. Okay, we will see how to solve, what are the steps we need to follow to solve this kind of differential equation. The differential equation what we are going to discuss in this session and few of the sessions moving forward, we will be only having first order and first degree differential equation. Okay, that means the differential equation we will not have. I repeat, the differential equation must not have this kind of stuff like d2y dx2, it will not have. Okay, neither it will have something like this dy dx, power 2 or more, it will not have. All these things we will discuss in our advanced session. All these things we will discuss in our advanced session of solving differential equation. In today's session and few sessions moving forward, we will be discussing the method of solving first order, first degree differential equation only. Okay. Now dear students, as long as the solution of the first order and first degree differential equations are concerned, we will be concentrating on three methods. Okay. The methods, the first method is known as the variable separation. Second method is known as the homogeneous differential equation. Third one is known as the linear differential equation. We are going to learn in this session for what type of function, what method we should follow. Okay? It all depends on, dear students, based on this, function. So if you see the differential equation dy dx, it is a function of x and y, correct? Now based on this function, that means based on the nature of this function, we will be taking the method of either variable separation, okay, or we will take homogeneous differential equation, differential equation I am writing as DE, or it will be a linear differential equation. Now based on that function, I repeat once more, based on this function fxy, okay, we will decide whether it will be variable separation, or it will be homogeneous differential equation, or linear differential equation. Once we understand which category it will fall, after that there are specific steps to be followed to solve it, and that we will discuss in the next sessions. Okay, we will have a session only for variable separation, another session on homogeneous differential equation, and another session on linear differential equation. Today we are going to learn that okay, based on what type of function we will take what methods. Okay. The first one is that variable separation method. The variable separation, the name suggests that okay, the function fxy, if we can make a product of two different functions, one of x and one of y, then this method is applicable. Let me give you an example. Suppose you have a function something like So this method I am discussing. Suppose you have a function like dy dx is equal to e power x plus y, for example. Now if you see this function e power x plus y, this is a function which having both x and y. X is independent variable and y is dependent variable dependent on x. But can we express this function as a product of two functions? Out of this, in the product of two functions, one function is of x and one is of y. We can. How? So from here we can write that dy dx is equal to e power x into e power y. E power x is a function of x and e power y is a function of y. E power x is a function of x, e power y is a function of y. After that, what we will do, dear students, that we will write dy by e power y is equal to e power x into dx, and we will solve. Okay, how to solve that we will discuss in next session, which is specifically dedicated to the variable separation method. Okay. So what we understood, dear students, is that if a function is of type, so if we have a function dy dx, if it is fx comma y, and if this fxy can be expressed as a product of two functions, one function is gx, one function is on x and another function of y, then we should apply the variable separation method. That is why the name called separation, because we are separating the variables x and y. Not all functions can be expressed as a product of two functions x and y. For example, if we have a function something like this, let me clean it. If we have a function something like this, that dy dx is equal to 2x minus 3y. That function 2x minus 3y you cannot express as a product of two functions, one a function of x and the other function of y. You can't. So in this type of functions we cannot apply variable separation method. So then how to do? Then there is a method called homogeneous differential equation. Now before starting that homogeneous differential equation, let us understand what is homogeneous function. Homogeneous function. Okay. What is homogeneous function, dear students? Suppose we have a function of x and y. Now if this function can be expressed as x to the power n into another function of y by x, we can say this function capital Fxy is a homogeneous function of degree n. Okay, I repeat once more. If that function capital F x comma y can be expressed as x to the power n into phi y by x. Phi y by x means it is a function of y by x. Then we can say this capital F x comma y is a homogeneous function of degree n in x and y. Let us take an example. Suppose our f x comma y is equal to x square plus 2xy. Okay. So what we can write here? So we can take x square common, and what we will get here? So in this will be 1 and here it will be 2 into y by x. Correct? So now if you see this particular one, that what is there in the curly bracket is that 1 plus 2 into y by x, it is nothing but a function of y by x, like 5y by x. So now as we are able to express x square plus 2xy as x square into 1 plus 2 into y by x, we can say this function, that is x square plus 2xy, is a homogeneous function of degree 2 in x and y. Okay. Now let's take another function. The function what we write here is that, suppose another function we have capital F x comma y. So let's write some other name, gxy. Suppose it is 2x minus 3y. Okay. So what we can write here, dear students, from we can take here x common, and what we get here is that 2 minus 3 into y by x. Correct? Clear? So as you see that this particular function, that 2 minus 3 into y by x is a function of y by x, and here x to the power 1 we can write. So we can say it is a homogeneous function of degree 1 in x and y. Now that homogeneous differential equation is applicable when the function is a homogeneous function of degree 0. Okay, if it is not of degree 0, we cannot solve using the method what we are learning today. Okay, so what does it mean? It means that if we have a function something like this, okay, so let me write a function. So we are discussing this. Suppose we have a function dy dx is equal to 2x minus 3y divided by x plus y. Now this function 2x minus 3y by x plus y, we can write something like that. In the numerator we can take x power 1, what we get, 2 minus 3 into y by x, and in the denominator also you can take x power 1 common, we get 1 plus y by x. So now this x power 1 get cancelled. So what we land up with, x to the power 0, and what we get here is that 2 minus 3 into y by x divided by 1 plus y by x. Okay, in fact we can give the second bracket. Okay, as you see, dear students, so this function, if we make this one, whatever I have enclosed in the black color, this function is like this. Phi y by x is a function of y by x which is multiplied with x to the power 0. So it is a homogeneous function of degree 0 in x and y, and this kind of function can be solved using the homogeneous differential equation method. And what is that method? That we learn in a separate session dedicated how to solve homogeneous differential equation. Okay. Now the next one is that linear differential equation. What is linear differential equation? Let us understand. Okay. So dear students, that linear differential equation, what type of differential equation will be known as the linear differential equation? If we have a differential equation something like this, dy dx plus p into y is equal to q, where p, q are either constant or function of x only. Okay, where the p and q are the function of x only, or it can be constant. Then we can say that this differential equation dy dx plus py equal to q is a linear differential equation. And there is a method to solve this linear differential equation, and that we will discuss on a separate session completely dedicated for solving linear differential equation. So dear students, in summary what I can say, by looking into this function that f(x, y), okay, by looking into the function, by looking into the nature of the function, we can decide whether we are going to solve this differential equation using variable separation or homogeneous differential equation or linear differential equation. I hope you got a very clear idea that how to proceed, clear idea on what? Clear idea on what method we should take to solve this differential equation. With this note, let me conclude the session here. In the next session, we will come up with the variable separation method. Okay? Thank you very much. Bye.